Hi everyone, welcome back to the Comptia Network Plus course, renaming the maintenance account. Network operating systems automatically give the network maintenance or administration account a default name. On Windows servers, surprise administrator, and in Unix it's root. So it should be crystal clear that if you don't change the name account, bad guys already have half the information they need to break into your network. The only thing they're missing is the password. By all means, rename that account to something cool and creative that you'll remember but would be really hard for someone to guess, and don't write it or post or stick it to the server. Here's a do not use list of names: admin, administrator, analyst, audit, controller, manager, root, super user, supervisor, wizard, any variation of the on the above. Managing passwords. Like any other aspect of network security, passwords must be changed, and doing that involves ensuring that all passwords for user accounts follow security guidelines so bad guys can't easily guess or crack them. You've also got to implement certain features on your network operating system to prevent unauthorized access. Basically, a strong password is some combination of alphanumeric and special characters that's easy for you to remember but really hard for someone else to guess. Like server account characters, that's easy for you to remember but like server account names, they should never be written down on anything that is then put on your desk or stuck on your computer. Unfortunately, this guideline is only followed in a perfect world. Users invariably try to make things easy on themselves by choosing passwords that are so simple to guess that someone would have to be seriously mentally challenged not to be able to. Let's look at some characteristics of strong passwords. Minimum length. Strong passwords should be at least 8 characters, the more the merrier, but they shouldn't be any longer than 15 characters to make them easier to remember. You absolutely must specify a minimum length for passwords because a short password is easily cracked after all. There are only so many combinations of 3 characters, right? The upper limit depends on the capabilities of your operating system and the ability of your users to remember complex passwords. Here's what I call the weak list of passwords. Never use them. The word password, proper names, your pet's name, your spouse's name, your children's name, any word in the dictionary, a license plate number, birth dates, anniversary dates, your username, your word server, any text or label on the PC or monitor, your company's name, your occupation, your favorite color, any of the above with a leading number, any of the above with a trailing number, any of the above spelled backward. Using characters to make a strong password. The good news is that solid passwords don't have to be in ancient Mayan to be hard to crack. They just need to include a combination of numbers, letters, and special characters. That's it. Special characters aren't letters or number but symbols like the ones we see here. Here's an example of a strong password: TQBF4 #JOTLD. Looks like gibberish, but remember that the famous sentence, "The quick brown fox jumped over the lazy dog." Well, this particular password uses a first letter of each word in that sentence with a 4 hash thrown in the middle of it. Sweet, solid, and easy to remember. You can do this with your favorite quotes, song, lyrics, and so on, with a couple of numbers and symbols stuck in the middle. Just make sure you don't sing the song or quote Shakespeare every time you log in. If you want to test the strength of your passwords to make sure they're nice and tight, you can use auditing tools like crack programs to try and guess passwords. Clearly, if that program has already has a really tough time or even fails to crack the password, you have a good one. By the way, don't just use a regular password preceded by ending with a special character, because a good crack program strips off the leading and tailing characters during decryption attempts. Password management features. All network operating systems include built-in features for managing passwords to help ensure that your system remains secure and that passwords cannot be easily hacked with crack programs. These features usually include automatic account lockouts and password expiration. Automatic account lockouts. Hackers and even people who forget their passwords usually try to log in by guessing passwords. This is why most network operating systems will lock you out after a few unsuccessful attempts. Some will even disable the account. Once that happens, the user won't be able to log in with that account even if they enter the correct password. This feature prevents a potential hacker from running an automated script to crack account passwords by continuously attempting to log in using different character combinations. When an account is on lockdown, network staff will have to unlock the account if the network operating system doesn't unlock it after a preset period. In any high security network, it's a good idea to require an administrator to manually unlock every account instead of setting the network operating system to do it automatically. This way the administrator will be sure to know about any possible security breaches. Password expiration and password histories. Unlike a good wine, even really good passwords don't age well over time. They just become more likely to be cracked. This is why it's good to set passwords so that they expire after a specific amount of time. Most organizations set up passwords to expire every 30 to 45 days, after which the network users all must reset their passwords either immediately or during a preset grace period. The grace period is usually limited to a specific number of logins, or it may allow a couple of days. Older network operating systems allowed users to reset their passwords back to their original form after using an intermediary password for a while, but today's network operating systems prevent this by employing password histories that consist of a record of the past several passwords used by a specific user. This record prevents users from using any password that's stored in the password history. If they try, the password will fail and the operating system will then request a password change. What this means to you, the system administrator, is that if your security policy dictates that passwords be reset every 2 weeks, you should make sure your password history can hold at least 20 passwords. This would prevent a user from reusing a password until the password is at least 10 months old, 2 changes per month. They'll forget the password by then. By the way, your more experienced users know about this history feature, and because coming up with a really tight password takes a little thought, with savvy users create ones they really like, they may have a hard time letting go. Maybe they just want to avoid the hassle of creating a tight new password and remember it. So they'll try to find new ways of doing it, that by getting around the password history feature. For instance, I knew a guy who actually admitted that he just changed his password as many times as it took to defeat the history lock, and then changed it one last time to his beloved original password, all of which took him only about 5 minutes to accomplish. You can force users to change their password to ones that are unique, because the latest operating systems require unique passwords and can, depending on the network operating system, store more than 20 passwords. This feature makes it a whole lot harder to revert to any previous passwords, but it's still possible for users to beat the system, so don't rely completely on it. Single sign-on. In today's modern enterprises, users can be overwhelmed by the number of points in the network where they may be challenged to identify themselves. Most users have to log onto the domain to have network access at all, and then there may be company websites that require an authentication process to access a database, SharePoint sites, secured drives, personal folders, and on and on. When users must remember multiple passwords, as the number increases, they may begin to resort to unsafe security practices such as writing passwords on sticky notes, hiding passwords in their drawers, and even sharing them with co-workers. All of these practices undermine the security of the network. Single sign-on addresses this problem. With single sign-on, when the user logs into the domain controller issues them an access token. This access token contains a list of all the resources, which can include folders, drives, website, databases, so on, to which they should have access. As a result, anytime the user accesses a resource, the token is verified behind the scenes and the user never needs to provide another password. Local authentication. When users authenticate to their computer, the authentication can either be to a domain or to the local machine. When local authentication is performed, the user's local account and password are verified with the local user database. This local database is called the Security Accounts Manager, SAM, and is located in Windows /Windows /System32 /config / In Linux, the database is a text file, etc. ECT passwd called the password file, which lists all valid usernames and their associated information. LDAP. LDAP. A directory service is a database designed to centralize data management regarding network subjects and objects. A typical directory contains a hierarchy that includes users, groups, systems, servers, client workstations, and so on. Because the directory service contains data about users and other network entities, it can be used by many applications that require access to that information. A common directory service standard is Lightweight Directory Access Protocol, LDAP, which is based on the earlier standard X500. X500 uses Directory Access Protocol, DAP. In X500, the distinguished name DN provides the full path in the X.500 database where the entry is found. The relative distinguished name RDN is X.500 is an entry name without the full name. Ldap is similar than X500. Ldap supports DN and RDN, but it includes more attributes such as the common name, domain component DC, and organizational unit OU attributes. Using a client-server architecture, LDAP uses TCP port 389 to communicate. If advanced security is needed, LDP over SSL communicates via TCP port 636. So I'm going to leave you there today for this video. If you like listening, please consider sharing and subscribing. Thank you.